Hello friends, my name is Assistant Professor Milan Patel. I am working in Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today I will discuss the design of a simplex lap winding. It is topic from the subject Elements of Electrical Design, subject code 2150904. It is a chapter 3 from the subject. So now, flow of contents. First of all, conditions for the simplex lap winding. Then problem number 1. Then calculation of it, develop form of this problem and sequence diagram of the above problem number 1. Then problem number 2, same calculation, develop form and sequence diagram, and previously asked GTU questions. So it is very important topic regarding our GTU examination. Now conditions for the simplex lap winding. So first condition is that the back pitch YB and the front pitch YF must be nearly equal to the pole pitch tau P. So first condition is that the back pitch YB and YB must be nearly equal to the pole pitch tau P. And second condition is YB and YF must be odd. So the value of YB and YF must be in odd digit. Third condition, they should not equal, but the difference between them should be equal to 2. Means the difference between YB and YB is equal to 2. They should not equal. And fourth condition is that the commutator pitch YC should be plus or minus 1. So commutator pitch YC should be plus or minus 1. In this, plus 1 is for the progressive lap winding and minus 1 is for the retrogressive lap winding. Then the question arises that what is the progressive winding and what is the retrogressive winding. If the winding is progresses in the direction from left to right, then it is called progressive winding. And if the winding is progresses in right to left direction, then it is called retrogressive winding. So last condition is that winding or resultant pitch Y should be even number. So resultant pitch or winding pitch Y should be even number. Now one equation is required for the finding the back pitch and the front pitch. So the equation is given by Y. Here this is one mistake. This is a YB. YB is equal to 2C by P plus or minus K. And again YB is given by YF plus 2. So simply we can get the value of YF from minusing 2 from this YB. So YF is given by YB minus 2, where C is equal to number of coils which is given in the problem. P is the number of poles. Then K is equal to plus 1 for the progressive and K is equal to minus 1 for the retrogressive as discussed earlier. So problem number 1. Design a simplex lap winding for 18 slots, 6 pole, 2 conductor per slot in developed form, and also draw sequence diagram. So this is our problem statement. So now first of all, calculations for the above given problem and winding table. So our main given data is that there is 2 conductor per slot. In one slot there are 2 conductors. So total number of conductors we can find by 18, which is the number of slots, multiply by 2, because in each slot there are 2 conductors. So total number of conductors is equal to 36. So from this 36 conductor we can find the number of coils is equal to 36 by 2 is equal to 18 number of coils, because we know that the coil is consist of 2 conductor. Now number of pole is equal to 6, which is given in the data. Now assume k is equal to plus 1 for the progressive winding. If in data if not given that progressive or retrogressive, then we have to assume k is equal to plus 1 for the progressive always. So now back pitch YB is given by 2C by P plus K. So 2C means this is the 2C, so 36. P means number of poles 6 plus 1, which is the value of K for progressive. So this value is 6 plus 1, so we will get the value of YB is equal to 7, and it is odd number. So our first condition is satisfied. Then front pitch YF is given by or obtained by YB minus 2. So it is 7 minus 2 is equal to 5. Again it is an odd number. So winding pitch Y or resultant pitch Y is equal to given by YB minus YF for the lap winding. So it is 2 and it is an even number. So our third condition is also satisfied. So now create winding table. Always winding is start from conductor number 1. So now winding table is like this. So this is number 1 conductor, and we know the back pitch is 7. So our next conductor is found by 1 plus YB, and here our YB is 7, so 1 plus 7 8. Now it is a lap winding, that's why next conductor of second coil is found by, this is a front conductor and this is a back conductor, that's why this is YF and this is YB. So YB is positive and YF is negative for the lap winding. So this is 1 plus YB is 7, so 1 plus 7 8. Now YF, but it is minus, so 8 minus YF means 5, so 8 minus 5 3 plus 7 10 minus 5 5 plus 7 12 minus 5 7 plus 7 14. So all these values are getting like this. So this is the winding table. One confusion will arise over here when the 29 plus YB means 29 plus 7 will occur 36, and our total conductor is 36. So then 36 minus 5 is again 31. Now 31 plus 7, it will 39. It is 38. This is 38. But we know that total number of conductor is 36. So minus this total number from the 38. So 38 minus 36 is equal to 2. Again, this is actually 38. So 38 minus again 5 is equal to 33. 33 plus 7 is equal to 40. And 40 minus 36 is equal to 4. Same 35, and this is 6. Simply we can write like this 1 3 5 7 9 like this, and here 1 plus 7 8, so 8 10 12 14 32 34 36, and from 36 remaining conductors are 2, 4, 6 and then 8. So this is a winding table. From this winding table we will draw the winding diagram in developed form and sequence diagram. So now this is a winding diagram. So first of all we have to draw all the 36 number of conductors. We know that here total 18 coils are there. So there are 18 front conductor and 18 back conductors are there. So first of all we have to draw 18 front conductor like this: 1, 3, 5, 7, 9, 11, 13, etc. till the last 35, and it is denoted by or defined by straight line, and its number is right in top of it. Now in between all the top conductor we have to draw back conductors like this in dotted form. So these all are the back conductors in dotted form, and its numbering is at bottom of the conductor. So these are 2, 4, 6, 8, 10, 12, etc. like, and last one is 36. So this is front conductor, this is back conductor. So now after doing this or draw this all these conductor, we have to follow the winding table. So winding start from conductor number 1. So 1 is connected with 8, and 8 is a 1 is front conductor and this is a back conductor. So 1 is connected like this to the 8, and 8 is again back conductor, that's why it is draw dotted form. Then 8 to 3, so 8 to 3, then 3 to this 10 to 5, 5 to 12, 12 to 7, 7 to 15, 14, 14 to 9, 9 to 16. So complete all the connections from the winding table. So after drawing all the conductors connections, our winding be like this. Now it's time to provide pole positions. Here total number of poles are given 6 and total number of conductors are 36. So by dividing 36 conductor by the 6 pole, these 36 conductors divided by the 6 pole, each pole consists 6 conductors. But from practical and theoretical view, the one pole, each and every pole cover only 70 to 80% of the coils. So we have to remain one conductor before the pole and one conductor after the pole, as it is not covered under the pole. Same for these two conductors are pole, this pole, this N pole, these two are for this S, these two are for N pole. Now provide names like this. First one is N pole, then S pole, N pole, then S pole, N pole, and S pole. One things must be remain that the adjacent poles should not same. So this and this will not occur. Always consider the two adjacent pole as opposite polarity like ns. Now after drawing these poles, we have to give directions to the conductors. So again there are 6 conductors under the one pole, so provide upper direction of current to the first 6 poles. Then next 6 is downward current, then next 6 coil is upward current, then again 6 downward, 6 upward currents, then 6 downward current. One thing should remain in mind that for n pole always consider the current direction upward. For s pole always consider the direction downward. Same thing, n pole upward, s pole downward, n pole upward, s pole downward. Now by completing these pole positions, now it's time to provide commutators. So first coil is completed like this. And this is the main connection between the coil number 1. So provide commutator 1 over here, then commutator 2, then commutator 3, commutator 4, 5, 6, 7, 8, 9, 10, and we know that there are 18 coils, so total number of commutators are also 18. So these are the commutator. Number of commutators are there. Now last thing, to provide brush for collecting the current or applying the current. It will collect the current in generating action and it will give the current in motoring action. So again number of poles is equal to 6. So in lap winding number of commutators are also same as the number of poles. So we have 6 number of commutators. So total number of commutators are 18. So we have to place brushes. Number of brushes equal to 6. So we have to provide by the same distance. So first brush is provided on the commutator number 1 and give the plus sign. Then add the number of 4, commutator number 4, again one brush is provided and it is minus, then remaining 2 commutator as it is, again positive brush, then this is positive brush, this is negative brush, this is positive, this is negative, this is wrong thing, this is by mistakenly placed. So now connect all the positive brushes like this. This plus are connected by each other, and this is minus connected by each other, and this is main positive, this is main negative. So this is the developed form of the lap winding. It is most IMP.
Now we will discuss sequence diagram. It is also very important diagram. It is also asked in GTU examination with the developed diagram. The main function of sequence diagram to show the current directions of each and every conductor which are used in the lap winding. So first of all we have to draw total 36 number of conductors like this. Then give the numbering. So all the bot top conductors are given by 1, 3, 5, 7, 9 till 35, and all the bottom conductors are given the names 6, 8, 10, 12, 14, 34, 36, 2, 4, 6. So now from the winding table 1 to 8. So this is conductor number 1 and it is connected to the 8. So from the winding table connect all the conductors like this. Now provide brushes to each coil. So now first brush is at conductor 1 and 6. So this is first brush. Second brush is at conductor 7 and conductor 14. This is third brush. This is fourth, fifth and sixth brush. So mark positive for the brush number 1, negative for second, plus minus. It is from the developed diagram. Now give current directions to the conductor which are placed at the brushes. For positive brushes mark upward direction. Now for negative brush mark both the conductor downward current. Same again for positive. For positive brush mark upward direction. For negative brush downward direction. For positive upward. For negative downward. Now it's time to remaining conductors. So remaining conductors are given direction alternate. So this is for upward, so downward, upward. Then both are downward, then upward, downward. Both are upward, so downward, upward. Like mark all the directions for the all the conductors which are used in the diagram. So then connect all the positive brushes like this brush like this, and all the negatives with each other by this, and give one common terminal for positive and negative. So this is the sequence diagram for the our problem. Now GTU questions which are asked in previous examinations. So this is the first problem which was asked in May June 2012. This is asked in winter 2016 and this is asked in winter 2015. So it is a very important topic regarding our GTU examination, and it is mostly asked in 7 marks, so very important theory this is. So thank you for hearing me, and please try by yourself at home. Again, thank you.